So our new shop, the back of it, minor problem. The last step is a bit of a doozy. So today, let's make a landing of some stairs. So the first thing we need to do is put in some pads right there to anchor the uprights. Now there are a lot of different ways we can do that one. In Texas, where we are out, we only have 4 to 6 inches of kind of a top loose gravel, dirt kind of stuff, and then it's pretty solid rock. So a lot of people can do, just like that bench right there, you can just rest wood right on the ground, and if it sinks a little bit, it's not going to sink much. A lot of homes in our area used to be built by just putting field stones on the ground and then putting your framing on top of that. And if you had some kind of base coming down to that stone from a very level framing, well, you could use different heights of those, I don't know what they call them, frame pieces, in order to level it out. But that's just not the Graham way. It looks soupy, but it may not be. Yeah, all you construction people, y'all can kind of make fun of me about my ability to make artificial rocks, but it's solid enough. It conforms to the limestone underneath. A little bit of dirt on top, but it shouldn't move from here on out. Now, building methodologies, I have a lot of options here. We built this workbench using the Simpsons stuff, and that would work great for a landing and stairs. I mean, just cut things to lead, butt joint it, screw it together. It's going to be solid. It'll last a really good long time. We could also just use standard carpentry practices. Lots of 90-degree chops on a miter saw, and just enough nails in the correct orientation so that they're cross length, so that they can't pull each other out. Good solid construction. But that just isn't really the worth the effort way, is it? Our way is to just totally overcomplicate everything and add in a lot more joinery, unnecessary joinery, and we're going to really overbuild it. So basically what I have right here are two views. The building is right here. This is a side view, and this is from looking at the view from the back, where that right there is the door. And it's basically going to be somewhat of a timber frame-ish style of platform and stairs. The main materials we are going to be using are 6x6s, which are about 5.5 inches square, and 4x4s, which are about 3.5 inches squares. The 6x6s were actually a ordering error on the building we have right now, and they are pressure treated. Personally, I hate working with pressure treated stuff, and Douglas fir is good enough outside, especially if you're going to paint it. So I'm just using what I have available to us. And we did buy about 10 4x4s out there, and I will go up back later and buy some 2x materials for the stairs and the platform. So what we are looking at right here is I just placed those concrete levels, and they are all within 1/4 inch of each other, so good enough. So no matter what, it's going to settle and it will feel flat to us. Technically, I probably should have tapered it back a little bit so rain would run off of it, but oh well. We're going to have 4 uprights for the main platform, and over to the side I will have 2 uprights that will support the stairs and a grab rail for Dad. All of the joinery is going to be mortise and tenon, except normally when you do a mortise and tenon joint, it's something like where you do it so that you have 4 shoulders all the way around. I'm not going to do that one on this example for the simple reason I want to maintain the maximum strength of these 4x4s in the up and down direction. If I put even a 1/4 inch shoulder right there, it would reduce it a little bit. And this is just, as I said, a timber frame-ish design. And I will be pegging them so that they can't back out any. We will have 2 shoulders. So basically the on top view will look something like you have your 4x4 and then maybe a 1/4 inch shoulder this way, and it'll come all the way over. So it'll get lots of strength there. Now normally when I do mortise and tenon joinery, the first thing I do is I cut the mortises, for the simple reason I might have a hollow chisel mortise or I have a specific chisel I'm using. But this is more timber framing. It's a lot more than a 1/4 inch or a 1/2 inch mortise. So on this example, I'm actually going to cut all the tenons first and then size the mortises to the tenon, because I don't have a single chisel that will be able to handle that big of a mortise. So it makes sense to do all the mortises themselves. The stairs, the only unique joinery we're going to have right here is, instead of having a straight across mortise, I'm actually going to dovetail the bottom of them so that the stairs will actually slide in and lock down, and then by putting pegs in there, it won't be able to rise up. There will end up being a little bit of an air gap up top. I'm not too worried about that because gravity will keep it going down. And that's probably that, and a through mortise for all the stairs to come through the side pieces to lock them in. That would be the only complicated joinery. Everything else is just cutting a tenon and a hole for the tenon to fit into, namely the mortise. So there we go. 4 short stretchers, 4 long stretchers. Now this is going to be a timber framing job, So it's not like making a tiny box where a 30-second of a gap will show up drastically. If there's a minor gap here or there over a big project, nobody's really going to care. It's going to be outside. It'll work. So for that, I'm going to cut the tenons with a circular saw mainly, and I want to get them consistently 2 inches deep on each end. So real quickly, I'm going to make a jig that's going to help me out cutting exactly 2 inches in on both sides. And there we go. When I make a cut, it's actually going to be 2 inches plus the kerf of the saw. If you want to get exactly 2 inches, you could just take that kerf width off right here, but that wasn't that big a deal for me. Now, as I discussed earlier, when you're cutting a mortise and tenon joint, generally, you cut your mortise first because that's dictated by the size of chisel you're doing, or the drill bit you're using, or the hollow chisel mortise you're using, or your router bit. Lots of different things, but it's generally easier to do that mortise first because you can fit the tenons fairly easily. It's an exterior cut, so you can shave away a little bit, or even add a little bit by gluing it on. But in this case, I'm cutting the tenons first because it's a much bigger cut and I don't have any tool that's dedicated to that, cutting that size of mortise. So the mortises, I'm going to experiment with using this thing. Just try out a new technique. What that means is I've got to make sure that the tenon I cut is at least wider than this thing right here so it can get into the hollow. So I'm going to set my saw to take off about 5/8 of an inch off of each side, and that should give me a nice sized tenon and mortise. So the whole idea for spending the time to make a jig that will cut a 2-inch deep shoulder over and over and over is because I have 8 stretchers, which means 4 cuts per stretcher, so that 48 cuts. Having to lay them all out 2 inches and stuff like that, the time I'm saving in the layout and doing the design so that all the stretchers are going to have that same exact tenon, the same exact depth, same exact thickness, the jig will save me time in the long run because basically now all I have to do is come grab any random one, just put it against something that you can brace it and make sure it's not going to move anywhere. And then just like when you're feeding something through the table saw, you kind of push it against the fence. You're not pushing straight against the blade, you're kind of pushing at an angle so it stays against the fence. Well, I'm going to now use this and I'm going to push this way to keep this nice and square. All I have to now come over here is set it up, find that square by rocking it back and forth. Flip it over, make the same exact thing, and then repeat another 46 times. But don't be like me and make the mistake of having one tenon going one way, one tenon going the other way. It won't work in the project. Make sure your tenons are going parallel. So to cut the tenons, you have a lot of different options. Obviously, me being a hand tool background, I would say draw the line, saw the line. And you can actually make a jig if you're doing a bunch of repeatable tenons, which on this one we have 4A16, 32, and each tenon is going to require 2 cuts, so that's 64 cuts. Well, you can make one template that will mark out both sides of this. You know, you mark a line out, reverse it, mark the line out, draw the line across, and that way all you have to do is get into the action of loading something up in your vise and sawing away. Other options would be obviously the bandsaw or any, not really a table saw because these are way too long to be dangling that way, but a bandsaw would be a very good option. But for those of y'all just getting started, there is another way, is you can build another simple jig for your circular saw. What I've done here is I've taken a piece of scrap 4x4 from one of the pieces I bought off that were a little bit extra, and I just found the center point of my blade as far as coming down, and then putting a 4x4 in there, I simply squeezed 2 2x4s and screwed them down. This one right here is actually anchored just via 2 quick little carriage bolts in here. Now the carriage bolt is smaller than the hole that goes in here. That's why you have 2 washers right here. And the whole idea is you put enough pressure on these washers to get it anchored. But I can actually take a little mallet and slightly tap it, and it will slightly move it one way or the other if for some reason I need to change my parallel. It's just friction holding them in the center of these holes, and there's a little bit of leeway there. And then that just offsets the distance here. So now all I have to do is I take my post beam that I've already done the cross cutting section, and I anchor it somehow. I've got my workbench that I have a video on how to make with only a very few tools, but it's got a nice flush front, so I can put a squeeze clamp up underneath here to anchor it down. It's nice to get it somewhat upright, but then I can grab my saw, just center it via those 2 2x4s, bring my blade up right there, and then making sure it is square by putting pressure on this side, just drop it down, and what I'm going to be watching for is for my blade to hit that bottom line. And you should be able to knock it right off and use a chisel to get those corners. There you go. A nice and easy tenon. So yes, it might take you anywhere between 10 minutes to an hour, depending on how many times you have to run back up to the hardware store, to build a 3-board jig that you can screw to the bottom of your circular saw. But from here on out, for the rest of the 64 tenons, it's just a matter of repeating the same steps over and over again. The key thing is just make sure it is fully registered to get that side, so you can get a nice square cut, and then just add up. $61 more to go. Now for the mortises, and that's mainly going to just be a lot of layout, but I do have some pretty different ways of cutting the actual mortises themselves using some more modern day tools than I've taught in the past. But mainly it's just going to be layout, and these are some, as I said earlier, leftovers from a misorder on the project, and I have one 12-foot one of these that I'm going to cut in half. I'm going to assume that the factory, the ends they have right there are square enough. So that's going to be my reference point for all the layout I do, because I'm considering that those foundations I laid out there are all within 1/4 or 1/16 of an inch. So if I use that as a reference, everything will be fine. and then I can trim the tops off at the very end. So with the factory edge down here being square, there's really only one absolutely critical measurement we got to get. We got to get the floor level all the way across. And we want it at 28 1/4, but we're going to have an 1.5 inch from 2x material being the flooring surface. So 1.5 inch minus 28 1/4 is 26 3/4. So I'm going to mark that as a reference on all of my boards and then make a line all the way around them so that I know that is where the floor is going to be. And if you do everything right with your relative layout techniques, the lines, even if you're slightly off, should line up. What I mean is, don't just go around as you mark it. Start on one corner, mark one side then the other, and then go here and that way. That way, if there's any error in either the tool or the parallelism of the board itself, at least you'll get a solid line going around that you can reference off of, even if it's slightly off 90 degrees. Now the first mortise layouts are going to be really easy because all of these boards are going to have at least one mortise facing each other so that they can come up on all four corners and connect. So we know that this is going to be the mortise length, and because all these boards are the same. So to figure out the baseline, all we really have to do is put our square right on that, bump this up right here, and we now have the other side of our mortise. Now, according to my plans or my rough sketch, the lowest stretcher I have is coming up 12 inches from the bottom, so it's easier to get maybe a rake or something out to clear anything out, and hopefully it being really open at the bottom, animals and critters won't want to stay down there as much. So I'm just going to mark up 12 inches, and that is going to be the base of the bottom stretcher. And once again, to hit the height of that stretcher, I'll actually just use a piece of wood. Bring it over, drop it against my square, bring my square over, mark the top. Now, here's the thing about timber framing. Actually, when you cut your joints, getting them dead flush on the face, in my mind, is a waste of time. That's fine furniture and stuff like that. If you give yourself a gap, in fact, if you give yourself a good gap, if one board is a little bit off from the other, because you have that gap there, nobody will know the difference. So, how much of a gap do you think I should do? I'm just going to use the thickness of this blue square. Measure it up there, and that's going to be where my board fits. And that right there will tell me exactly where I want my mortises to be. And voila, I have my first mortise totally cut out, the section where it's going to be, but I need to transfer that to all of them. So the easiest thing for me to do now is to make a jig that I can use for the entire project. I now have a lot of my tops and bottoms, I just need to get this distance. And precise layout jigs can be easily done out on a job site, even with just a circular saw. As long as you're taking advantage of like factory edges and stuff like that you know are straight, you can come up with a jig. I've got 90 degrees over here, a center divider that's parallel right here. I showed how to make this in one of my table making videos, and this allows you to get table saw quality 90-degree cuts because you reference that factory edge that's straight right up against here. First cut this side so you know it's parallel, and then you do the other side. So I just need to make sure I get over 7 inches on this setup right here. There we go. And make my cut. But don't cut into your good boards. nice zero clearance cut, smooth and straight. So what we ended up with was just a little jig. I have a cross member right there so I can bump it up to stuff. I got the spacing as we drew on the board right here, and the tracing allies just fine. And I went and tested it, and everything either fits just perfectly or is a tad bit tight, which is exactly what we want. So I now have a jig for drawing all the tenons. So for here on out, if I have any kind of layout line, I can now draw the tenon by just tracing the inside of this little square. All I need to do is get one reference line, whether it be the top of it or the bottom of it. And because this one and this one are going to be matched pairs, the offset is not the same. So I do need to make sure that I alternate my offsets so that the stretchers won't be cockeyed. Now, not that y'all are stupid like me, but I cannot stress this enough. Before you start removing fibers, before you start drilling holes and cutting out mortises, go ahead and stand them up and make sure all your mortises are going to line up. All the high ones go where they go, all the low ones go where they go. Just dry fit it, so to speak, and make sure you haven't made a major mistake. You wouldn't believe how many times I've cut up all of my parts to find out that on one of them I put the mortise on the wrong corner. Now, I don't trust glue, especially in the outdoor project, so we are going to be drawboring all of these joints to keep them locked together. And what that means is whenever I mortise this down through, I'm going to put a peg that's going to wind around and really sink it in going this way. Which, in order to do that and get a nice clean hole so we don't blow out the center section, it's best to go ahead and drill the holes for the cross peg before you do the mortising. Now, once again, because I don't want to have to redo all this layout, using the same jig with the same reference section, all I have to do is I can line it up here just close. It doesn't have to be perfect. And then just get it started with the drill to locate the points, and then go ahead and drill them through. And that should get us pretty much. Then it's just a matter of flip and repeat everywhere you need those dowels. So now we've got to clear out the mortises we laid out. And once again, if all you have is a chisel and a mallet, you can get this done. It's just going to take a little bit longer. Generally, my rule of thumb is if it's less than a ½ inch or 3/4 of an inch, I'll do it by chisel because I don't see it saving much time any other way. But once you get into bigger mortises, for example, when you're building a timber frame-ish staircase and landing, it makes sense just to go to powered means. Now, one of the first things I do, and it's gotten into something I do even on when I chisel something out, is I will drill a hole in all 4 corners. Invariably, I end up spending more time clearing out the waste of the corners than just about any other part. So if I just drill a hole right in the corner to begin with, I don't have to deal with too much of it. Now, this is drilling really fast just because it's pressure treated wood. This thing is sloppy wet. It's one of the reasons I hate working pressure treated wood. But it does make getting rid of fibers a lot easier. Next, I used to take a chisel and I would kind of whack all the corners, the lines straight, just to break those fibers so I would be guaranteed of getting a clean edge. But I have a new tool. This should work a lot better, and it's going to give me a nice straight wall going down at least 1.5 inches for me to get most of the waste out of the way. Now, some tricks I've found on using this thing accurately, it has a lot to do with, riding a mountain bike or anything like that, motorcycles and stuff like that. The more contact points you have, the more control you're going to have. So I actually have one hand resting on the wood and holding this at the same time. It gives me a nice pivot point, and I'll actually put it against my chest and my cheek, and by putting it on the cheek, I get to look straight down the blade so that I can somewhat aim it. Now, this is one of the situations where, because I use that layout tool to mark the squares, I was marking on the inside. So this is a situation where I want to take the line. So all I gotta do is aim for the line and plunge down. Now, just like with the chisel where I was just kind of getting the edges all the way around, I don't have to go to full depth right off the get-go. So, the fact that I got, 1 inch in, that's a bonus. Now it's time to just waste away the material. So just get any kind of drill bit, a Forstner bit if you're using a drill press or one of these, and just make sure you don't touch those edges, and then just waste away material. You will notice I have a little flag right there because that is about 1/4 inch deeper than my mortises need to be. And just like that, the hard part is done. Now all we need to do is either using a chisel or that vibrating tool, just break out the rest of it. And now with about 1.5 inches removed, you can come back here. You've got the holes drilled all the way to your depth. All we're doing now is clearing off the top. So in cleaning up the walls, my 2-inch depth just so happens to be about right there. So if I get past this little lip right there, I know I'm at my depth. All the waste got cleared out with the drill, and now I just need to smooth out the wall. And there we go. A nice, clean tenon wall. 17 more to go, and we'll be ready to fit all the individual joints.
Come on, I'm tired of waiting on you. Just go away. I got a better idea. You're just taking way too long.
Just take the jigsaw and go in slow.
And it's done. Done, Sean. Now I can get back to something productive.
So now that all the mortises are cleared out, my dad's off on back for how I cut them out, we now need to fit all the tenons. And yes, some of them are going to be loose, perfectly fine. This is just a timber frame-ish design. But some of them might be a tad bit tight. You know, maybe because Dad cut them, not, well, I think I cut this one. But, you know, they might be a tad bit tight, so we just need to refine it. And for that, I highly suggest just grabbing a Shinto rasp. These are really cheap. They're like hacksaw blades. And, you know, just lay it on its side. Give it a few swipes. And take it off. You can really fine tune it that way. But the problem is, each one of these might be custom fit. So the first thing you need to do is label them all. Put an A on the bottom, this is going to be on the inside, and maybe if you don't want to mark on your material, grab some blue tape and mark that. That way you know the A tenon goes in the A mortise. And if you need to remove a little bit more material, just bump up your stock, brace it on your arm, and just grab a chisel. In timber framing, this would be called a slick. You'd have a really big one that have a canted lever so that you could sit it on flat. But, you know, use what you got. Right now, I have a 1-inch chisel. Now, once you got it pretty seated the way you're going to like it, go ahead and get some kind of bit that has a tip on it, and then push it into the hole you built for the dowels, into a seat, and give it a light tap. You want to find the center of this hole on the piece right here. Now, FYI, here's an excellent example of a way you can get a tight fitting joint on the show side, is cut a little bit farther back on the non-show side. That way you're guaranteed it's going to fit tight on this side, and it might be a little bit loose on that side, but the drawboard is going to bring it in tight, and you'll still get a good fit, because as long as it's tight on the outside on all four corners, you got a solid square. I did this one by hand for the simple reason I forgot I was putting an arm rail, and I needed to cut an extra one of these, and it just wasn't worth my time to go ahead and set up all those jigs with a circular saw just to cut one. That's the time where you just draw a line and saw the line. Now, once you've got those center points on, go ahead and remove the tenon. Notice you have those center points there, and we're going to drill 2 holes. That tap basically gave us a point where if we drilled a hole right here, it would be in line. That's actually not what we want. I actually want to drill the hole a little bit in front of it. And because this is softwood and that board right there is extremely wet wood, I know it's going to compress a lot, so I might even go even farther forward than I normally would on like a furniture piece. Now, if I drill the hole right here, well, when the peg comes in from the outside, it's going to hit here, and it's going to actually have to curve around, and it's going to drive this piece of wood that way, thus sinking this up with the whole frame. And that's what it means by drawboring. You're drawing it into the shoulder so that you get a very tight fit. Plus the fact that now this board the dowel has to wind its way around, so it's in a bent position. It's not coming out. It kind of binds itself in there. So with no glue whatsoever, you get an extremely strong joint. Do that to every single tenon, making sure you keep them in the right order. Remember, this side is now going to have an opposite end that has to line up. But after that, we get to start assembly. Now once you've got all those drawboard holes cut, everything else is just going to be cosmetic as far as the frame design goes. I'm going to be lazy and I'm just going to cut a pyramid on top using the same angle on all four sides on the miter saw. But if you want to stick it on the lathe and turn a newel post, have at it. Other things you might consider doing is maybe taking your router and rounding over all the corners and stuff like that. Sanding off any of your witness marks or anything, or pencil marks. But we're going to be painting this. It's going to be outside, and this is pressure treated lumber. Nobody expects it too much out of it. As I said, it's timber frame-ish for us. So right now, I'm just going to cut some pyramids. Okay, now comes the fun part where you get to vent some frustration after spending all this time building it. We're going to now start assembly work. And this is one of those cases, because we don't have to use clamps or anything like that, it makes sense to do it in stages. Plus it'll be a lot lighter that way. So I've got one of the pieces right here. I've got my corresponding numbers and letters. So we will start with letter A, using Tight Bond 2, simply because it will be an outdoor project. We're going to really slather it into the mortise, not being too delicate. Now this is one of those situations where every single glue joint in here is a end grain to long grain. So it's not the strongest glue joint there can be, but that's not where the strength comes from with a mortise and tenon joint. The strength comes from the shoulder to face section, and in this joint, the drawboring, because the pegs are actually going to have to work their way around. So whenever you're putting glue in, be sure and get just a little bit of glue into the holes that you drilled. And that will help secure the pins themselves. And because I'm not too stressed about it, I'm just going to do all the holes at once. Now making sure I get all the letters going in the right position. Just drop them in. You have to bang them down, go ahead and bang them down. Now Dad was kind enough to make me a bunch of these dowels. The key aspect is they do not go all the way through, but neither did the holes, so they're going to be a little bit proud. So you can either cut them short or leave them proud. And notice he tapered the ends. They're rounded on the ends because all these holes are offset. I wish I could show you, but they are deep enough that the camera won't show in there. But the key thing is, I want you to notice, I'm leaving a little gap right there. So as I drive this in, watch it tighten up that gap. See? Also notice how the pin is now moving back this way, because it's actually arcing forward, and it's got to arc back around, so it's going to straighten back up in a second as I keep going. There we go. And that is not coming loose. So pardon me while I go ahead and attach the other side of this. We'll get two sides out there, we'll take them out back, and we'll finish up the frame installation, the frame assembly. Now guys, don't be stupid like me. This is not going to be seen. I should have put a bevel all the way across this, because right now this corner right here, well, evidently this board is slightly twisted, so that corner and the opposite corner are hitting. If you had a bevel right there, it would kind of find its way into the hole. So now hopefully when I lift it up and position it, see, that corner right there just snuck right in. So now I can bang it in and it will seat. All I need to do, cut that little corner, or put a bevel and it goes together a lot easier. And line up those center lines and clamp it down. Now not only are you going to want to mark both sides, but you're going to want to mark underneath here too, front and back. Now these two lines right here, the top one is the one we marked out for the mortise over here. This one's a mark out for the bottom of the mortise here, and because they are flush, this distance right here is the amount we need to remove in order for this top board to sit down into this one and be flush with the top here. So go ahead and take that measurement. For me, that happens to be the thickness of this piece of plywood I had running around, a 1/2 inch plywood, because I like measuring off of stuff I have, so I don't have to pull out a ruler that often. So to make the dovetail, all I'm going to do is I'm going to mark my top on both sides. Tell myself I'm going to be cutting off from here, coming down this way. And then on this board, I simply take the same piece of wood, mark my line across, and I know I'm going to be cutting down on this side over here. So real quickly, I'll come over to just this side of the line. Remember, on this instance, because the pencil was on the outside of the board, we want to leave the line. Go ahead and start my cut. Come down to my baseline here first, and then I'm just going to right saw up until it kisses the back of the board. And that's it. Do the same thing to the other side, and the same thing to the back. Then I like to just make a few cuts in the middle to get rid of some fibers, to break up some fibers. And it's just a matter of whacking it away. Remember, this is timber framing, so it's not ultimately precise. It's good enough. If we're within a 32nd of an inch, I'm sure Mother Nature will be happy, because the wood's going to be moving. And if you want to, there's no reason you can't clean it up with a shim toe. Good enough. An alternative would be to just put in a little lap joint right here. But if you do a lap joint, you're going to have to peg it a unique way, and I'll show you that to you in a second. will say I kind of like having a ruler on my blade. Making marking depth a lot easier. Now, since I'm doing a lap joint on that side, I really don't have to do anything over here, but I do need to cut the dovetail on this side. So all that it is I've already got the lines I need to draw. I've drawn, so come on over, get started, come down to the baseline on this side. Easy peasy. Right it up, bring it across the top. Saw flat until you hit the baseline on this side and that side. From here, we need to make a gradual slope from the bottom of that to the line we marked. Remember, we have a little bit of an overhang. And what I typically like to do is I would take my chisel and I will make a pretty steep V right here down to that baseline. Now all you have to do is slowly remove material. As long as you never touch that baseline right there as you come back, you're going to have the slope you want. Each time coming back a little, angling it a little bit less. That last one, just kind of carve it down. Keep doing that all the way across and you'll have the bed you need. So now you should be able to just plop it right on down. And the dovetail on this side will lock it in this way. So it's not going to move this way or that way. And lap joint on that side, we'll keep it moving from left to right the other way. So that piece is locked in, but we can improve it. The camera was turned off. I don't know why, but the key to locking these down is a dowel. And you'll notice that the dowels are kind of not even. It's because one of them I had going radically this way, the other one I had going radically that way. So if it's clamped down and then you drive the dowels and it angles, the only way this is ever going to come apart is if the glue bond breaks and the dowels themselves break. And I did that to the same on the lap joint, because if it is, the dowels are actually dovetailed, it can't lift out. Next we're adding decking, and because I'm truly lazy and I don't want to do a lot of measurements, I'm going to put 2x4 over here that I'm going to clamp down to the back side. That way this back edge right here, I know I can get level if I bump all the decking boards straight up to this. And I only have to worry about leveling out that side over there. Next I'm going to find the center of both sides. And once again, because I'm lazy, a lot of times I kind of just rough guesstimate what that center is. So I'm going to guesstimate 18.5 right here, just roughly doing that one. And then if I take that same exact measurement this way, 18.5, my center is in between these two lines. Pretty easy to get center when you do it that way. Now we're trying to save money, obviously, so I'm scrounging around to the leftovers from the framing job. As long as I can find 15 2x4s that are over 67 inches, which is an inch longer than I actually need, I just need to process one side of them to make them into decking material. And by process, I mean putting a heavy round over on 3 of the 4 sides. I'm going to leave this one square because I'm going to cut it off anyways. first board, I take my center line, I come over to 1 3/4 of an inch, which is half a 2x4. Draw myself another line on this side. I've got a center line over there, so I can take the center of this board, which has the round over on that end, line it up with the bump board, line this board up over here, drive in 2 nails. Then it's just rinse and repeat until I bump up to both sides. Now I am new to power nailers, so somebody down in the comments tell me, why are they consistently bending over on the very top? That'll work. So there you go. A nice sturdy arm bar to keep us from just falling off that way. But it's removable, so I can actually back my truck up right here and just load straight off the bed into the workshop. And that's kind of a good stopping point for today, because as you can probably hear in the background, the roofers are here, and I want to stay out of their way and let them just blast through it and get it done. Then we can move on to the next step of insulating and stuff like that at the workshop. But one of the things I want you to remember is this was basic mortise and tenon joinery. It's stuff you use all over the place in woodworking. So if you ever have a small project, or I just published a whole series of videos of building a router table, which was frame and panel designed, that used mortise and tenon joinery. So you learn some basic techniques, and yeah, Tools might change, but the techniques are kind of the same. The principles are the same. You still have to deal with edges and grain. So in the next episode, we will continue the exploration as I go ahead and build the stairs coming out from this landing. I hope you enjoyed the video, picked up quite a few tips, but the one last thing I want you to remember, that it is always worth the effort to learn. Great stuff. Share it with others. Y'all be safe and have fun.